God, what are we looking at here?
Oh, I mean, this one's weird. I'm just because electric arcs on transformers. I just put it, but the birds see it before it's coming. Watch this. See, they're
always sent it
beforehand, right?
They all left.
Yeah, they all left right before it happened. Yeah.
Speaking of senses, that's a sense that we don't have, that all animals inherently have. Before the storm, they're always running. They always know calm before the storm. There is those telluric currents in the ground, and before an earthquake, as David Ben Davidson was showing earlier, you know, there's all sorts of these electric warnings.
Continuing the March 18th edition of the Electric View, we explore the nature of the electric currents flowing through the planets and how planets process these electrons. Telluric currents are induced underground, but if we accept the fact that they're induced through the air, just like the ionosphere moving and the currents moving from the poles to the equator, are creating a movement of charge, and this movement of charge affects air and creates loops and so forth, and the same thing occurs when you are underneath the ground. The difference is that different parts of the ground have different conductivities, and just like water flows downhill or flows through the path of least resistance, telluric currents do the same, but they are flowing through rock. So they can build up in certain areas, get an insulated layer, and then break down as they go through it. Stuff like that. So this idea is very interesting.
So for a human,
sorry to interrupt. Question there, Neil, about these telluric currents, right? These charges moving. Mm-hmm. Would ocean water be a conductor or resistor?
Well, that's the thing. It's resist. It's not a semiconductor. Brine will conduct. Dirty water is a fairly good conductor. However,
right. That's what I use for spray.
And you're right. It is a fairly good conductor. However, pure water is an insulator, as we probably know. But
more or less, yeah.
More or less, for lack of a better term. But because of the shape of the ocean, the fact that it's a large, flat surface, electricity from the air will want to go to the highest points, as you know.
Are you
and
implying
there's no high points?
Yeah, okay. But what? Would a telluric current going through the Earth's crust hit the ocean? It would seek that path, probably.
They move through it all the time. I would suppose that's exactly all the volcanic activity that's happening in the mid-oceanic ridges. All of this is nothing but vibration constantly excreting out, and you know it's sound, it's sonic, and it moves through the water and it moves through the earth, and it's connected directly to the Birkeland currents that are connected to other planets as well. We have backflow and forward flow from different Birkeland currents.
I have to argue a conceptual point. I'd say anything that's not a superconductor is a semiconductor.
Thank you. I would say that we're an insulator. And I would also have to say that it has to do with the alkalinity of the water as much as the ppm, as much as there's, amount of debris within the water.
Well, ocean water has a lot of salts and stuff in it. So my guesstimation is it's fairly conductive, especially.
But it's also incredibly thick, though.
But if you compare it to rock, right, rocky material, then the ocean water will definitely be more conductive, right? Or the conductive.
It depends on the rock. Basalt is highly conductive, and that's
but if rock would be mostly a silicate, because not only would it be the sand and all of that runoff from the sand, right? It would also be like decomposing animals and
sure.
like that. So that silica would also, I would think, increase its conductivity. Well, because I also think about like the conductivity of nanoparticles increasing within water, like when things are broken down into their smallest forms, then their conductivity increases in a way, right? Depending on what it is, obviously. But so that's what I think of, and also yes, the pH of something, its alkalinity or acidity will affect its ability to conduct. So
yeah.
Would it be so maybe, I mean, with the oceans being obviously fluid, but also temperature differences change alkalinity and can change conductivity in that sense.
What exactly are we arguing about? Are we arguing about if electric currents can be moving through the ocean and the earth as well, or just one or the other? Or
which one does it better, I guess, is what we're arguing.
And also, I would think to what degree and what place it is, right? Because water is different.
It's variance, and then there's gradients.
Can I throw a curveball in here and add to what my interpretation of this is? I see hot and cold currents moving through the atmosphere, and they move through the atmosphere. I see hot and cold currents moving through the oceanic conveyor belt. And they move, and they're constantly moving and pulling up water from one to the other. And I'm wondering what that has to do with the that would create electroflow. Am I correct?
Actually, you are absolutely correct. It's the same actual thing in the air. The conveyor belts, in my mind, even though they are obviously based on some sort of heat and so forth, they're not entirely, just like we use meteorology to determine weather patterns, and we only have a heat model to do that. And that's why it goes out of whack. We can only predict like maybe 3 days in advance, 4 days, 5 days tops. But if we actually understood it electrically, we can begin to see the patterns that are really happening. And the currents in the ocean should also be doing similar things. They should be traveling, like anytime you have water traveling in a direction, or air even, that's a current. Like literally an electric current. Material is moving along with that. And those things are carrying charges. These charges can try to dissipate like it's a leaky wire to the water surrounding it. But as you know, plasma tends to create barriers to separate themselves. And it's just very interesting. If we are studying this now, this is not something that's being studied at all now by any institutions. I'm sure that maybe some are doing something, but on a large scale, to say, okay, we're just recently finding out that electricity is the jet streams, is a ring current, for example, and that there is a quote unquote jet stream under the ground that they think is a river of molten metal, but in actuality is probably just a current of electricity because they're sensing the electrons traveling inside the Earth. And so just like there are loops through the atmosphere, Birkeland currents moving left and right, coming into being and disappearing, there should be similar things like this in the layers of the ocean, just like there should be in the layers of the Earth, all the way down to the core. So this is a layer upon layer upon layer, all the way past the atmosphere out into space. So,
right.
These are all different examples of the same phenomenon. The cool thing is, though, the closer you get inwards, the more things start to get concentrated, because obviously the same force that's outside of, say, the magnetic shield, we'll call it the magnetosphere of the Earth. Well, all of those particles that are moving up there should technically also be moving underneath the surface of the Earth. So if you see how many are moving above the Earth and you just press them down so that they are now in a smaller area, then put them in rock, that's the same amount of power. It should be anyway. The equation should equal. So it's very, very interesting. So we don't exactly know. There should be a negative ionosphere under the ground somewhere. Like there should be like an opposite ionosphere inside the Earth. That is something that we've not really, tried to explore yet. But see, this is where the Telluric currents come in. It's very interesting.
That's where I'm going here.
And it's a good question. Definitely. And I will love to help you with that later.
Yeah, we're going to zoom in on that, definitely. Good stuff.
I agree.
So, but what I'm getting here, just from a quick scan from Wikipedia and Britannica. Encyclopedia Britannica. Those are the two that I dragged into the chat window there. What I get from it is that the outer ionosphere, as you point out, is basically, if I may say, inductively connected, or other ways as well, connected to the telluric currents that are going on underneath our feet, right?
Correct.
And that's pretty much mainstream as far as I can understand it now.
Yeah, we believe that telluric currents, I mean, they understand that you can follow them. You can follow how, something will charge up as the day goes by, and then you can see it start going down again as the sun passes and so forth. Because the sun has a big effect, because obviously, even though you can say, no, there's nothing on the Earth that is actually, but that the photons are sitting there, they're hitting things, and they're creating electric charge by them, even in semiconductors and stuff. Maybe minor, nothing that would affect your equipment, but over the whole surface of the Earth, yes.
Yes, indeed.
Isn't that where the wind actually comes from? From the sun? That I think who was proposing that? The guy who came up with the fourth phase of water?
Pollock? Gerald Pollock?
Yeah, I thought he was the one proposing that the sun creates the wind because it heats it up and everything becomes positively charged, and then due to everything becoming negatively charged at night, and then if I was following that correctly,
I think it was the other way around, but yeah.
Michael Claridge had very similar.
So more electrons, and then it loses its charge, right? And it becomes more positive again, and then it starts to rain, for example.
Yeah. So it's like it's always a balance between this. It's always just hot and cold. If you think of everything as just warm things becoming hotter and colder, it seems like all of these patterns are on every single layer of all of these levels of reality. Is this condensate, condensing, expanding modality to it. And I'm finding that all of these currents use this to move through the ether-like quality of plasma.
You've also got, with temperature, that TEMP right in the front of it, just to get more esoteric, if you like.
Well, if you want to actually, one of the things that is often missed with regards to electricity is that it's not magnetic fields don't generate electric currents. Moving magnetic fields generate electric currents. So this is why when you have the sun rising up and going down, it's just before dawn, like between 3 and 5 or so in the morning, when these currents are starting, the sun is about to come over the horizon. And when that starts to happen, charges start building up. And and that change in magnetic field strength induces currents along the ground, which then travel around the planet and do this every day. Now, this is not
smell it.
Yeah, you could probably smell, especially when earthquake lights start happening or other phenomenon like that. But we're just beginning to explore this ourselves to be able to go, okay, well, this is actually happening. And of course, certain places in the ground, studying where these currents go in and out of, is the study of feng shui or geomancy, which is, if you go to the old books that they were into, they were telling you how to build, where electricity or where the dragons will come out of, like where ponds are and stuff. And this is how they lived. And it was, that must have been beautiful to be able to see the currents traveling all over the place. In the air.
And that was because of the, tell us more about the process of what you're talking about, the ionosphere coming closer to the Earth, I believe.
Well, I was just talking about anything that would increase charge. But anytime, if you have an increase of charge, you're going to have the ionosphere. If the voltage stays the same, so the distance between the ionosphere and the ground stays the same voltage, then, but you can put more charge on the plates. And if you put, we'll call them plates for this example, but if you put more charge on them, they'll get closer together. So if say the Earth moved into an area which had a different electrical environment, say around another planet, or something happened that the sun's charge got bigger and suddenly there was more electricity traveling by the Earth, then the Earth would react by compressing its field. And this would mean that the volts per meter go up. So it's 120 volts per meter now, and then if I make the ionosphere dip in, say twice as much, it will double that, so it's 250 per meter. That might not do too much. Now, let's say we make it times 10. Well, then it drops to 5 kilometers, which is just on the other side of the atmosphere. It's within the atmosphere, really. Then it would be 1,500 volts per meter. If I did that times 20 and keep knocking it down, if I did it times 100, it would be 500 meters off the ground, which is about, the height of, say, a pyramid. And there would be 15,000 volts per meter. So every time you went 1 meter up and held a stick above your head, there would be friggin' a coronal glow coming off of it, because that's how much charge there is in the atmosphere. And this is giving you an idea on what they may have lived in if this was the case. Now, I don't know if this is the case, but I can make some educated guesses that you don't build stuff like that unless you had a purpose. It's the same thing as building like a hydroelectric dam. You're trying to build for a purpose. These things seem to be even more, they seem to some of them attain their ritual significance only later. It would be like us living, 100 years after the fall of this world, and for some reason we don't have a river there now, but we would live inside of this hydroelectric dam, and we would go, no, this thing can make power if we just worship it the right way.
Right.
It would be, it's that kind of thing. That's my mental thinking on that. But
so let me get this correct. So, and some of your hypothesis is drawn possibly from the mountains starting to glow. They see that the tips of the mountains start to glow, and so therefore, if they build a mountain tall enough and built it so the fire can come down the center, which is
the word pyramid, actually.
Volcano,
pyramid, right? Exactly.
Pyramid, yeah. Fire down the center. So is this? I mean, you also claim. I remember you saying that the mountains on Venus are already glowing. What's
That's
going on
true.
with this?
That's true. They think that the mountains on Venus have metal tips on them. Okay, if because they use radar, right? And so they're using a Venus orbiter or whatever it was, and it's looking through the clouds because the clouds are very opaque. But when they go in, they do a mapping of Venus's surface, and they notice that the mountains appear to have metal tips on them. Now, I don't think that it actually had metal tips, and neither does some of the people from the Thunderbolts. One of the things that they noticed was that plasma reflects radar waves. This is one of the reasons why I think when they're chasing spaceships, like UFOs, they can see it, and then they see it's on radar. Well, it should be, because it's plasma. You should see it on radar. It's the same effect. So I think that these tips of those mountains, which they never viewed with their eyes, they're only using computers. This is as close as they got, these shots here, the Viking lander lasted 15 minutes? And that was it. It was toast. So, the tips of these mountains were probably glowing. Now, if the same thing happened in the past, if it hit a certain point, like a really concentrated, it would start eroding the mountains. They would start melting, it would look like, because it's pulling ions off of pieces of dirt, and it would just keep ripping them up until they got lower and lower and lower, which would be incredible amounts of power. But before that, they would just be glowing a little bit. And I think that if they noticed that situation, they would learn to control it, or build something to mitigate it, or otherwise control it. And it looked like that some of these structures are like capacitive mountains. They have an insulator around them, and the core can conduct electricity and so forth, which is why sometimes they learn just to build piles of dirt and then just cover them with a surface. You didn't actually need to create the effect. I mean, you didn't need such a beautiful piece of work like the Great Pyramid, for example. You could use other things. Obelisks could do it, probably. Stuff like that. But this is all, as I'm saying, supposition. But it's educated supposition.
Well, speaking of someone who doesn't do much supposition, Stephen Crothers, he just commented on one of my things, and I was like, oh boy, wow. He said it was cool getting to meet him in person, but one of my things in the Electric Universe. He commented on.
Oh, that's good.
Nice.
Oh,
Yeah,
as an aside, this Viking lander that you're looking at the footage of, it had diamonds for lenses.
Wow.
When it landed, it lasted only 15 minutes because of the fact, and these are the shots that it got back in 15 minutes. But this is in the late 70s, mid 70s. I don't know exactly when, but it was the atmosphere. Even though it looks kind of nice there, it is 50 times the atmospheric pressure on Earth, and it's
89.
89.
89.
Sorry.
89 times
Nice.
pressure. But I'm just saying that's like a considerable amount more than 50. It's insane. And it's like sulfuric acid.
Yes.
And
it's 900 degrees Fahrenheit as well.
What are we looking at? Is that real pictures
of Venus?
Lightning strikes on Venus?
They got this?
The light from the lander, notice how there's no sun per se. They only have a general idea where there's shade. And the reason that is because they found that the light was coming from everywhere. There was near constant lightning strikes around the lander that it just created a haze of light. Like the whole inside the atmosphere, the aurora was active all around Venus to the point where you could, it was well lit. Even though the atmosphere is so thick, the sun couldn't penetrate down that far. So,
dude, things could probably that
looks like a bear trap.
That's the edge of the lander there.
Live off of that energy, that type of like exothermal energy or something from the electricity and the luminosity. There could be life forms that could live off of something like that. I never even thought about that. The electrical just off of the light and the heat in the atmosphere.
Well, there is actually, during the Carrington event, there was some discussions about people who woke up early because the aurora was so intense they thought the sun was out, and there were people who were reading newspapers by it, and so it can be quite bright depending on where it's located. So I envision this is what they were dealing with there in the past. But anyway, go on.
I brought that up actually. I have that in here.
Yeah, I think that's where I saw it.
Yeah, it's pretty interesting.
Neil, let me ask you a question there for a moment. If I have a metal ball, just an iron ball, and I charge it up with lots of extra electrons, what happens?
Well, you've seen a Van de Graaff generator.
Just talk fundamentally to me. Fundamentals.
Okay, but
what happens?
Okay, if it's
there's nothing else there, right? Just the ball and electricity. So let's just say then that you have a ball and it's immersed in a plasma. Basically, is what you're saying. Okay.
I'm getting that feeling. So what you're looking at is a ball of homogeneous material, and you said iron, I guess, or metal.
Yep.
It will have basically, if it was a different charge, which it probably is, given the fact that it's not the plasma around it, it will form a shield around that ball because it will have its own internal charge different than and it will attract charges to it. So it will just have a sea of electrons or protons, whatever, or ions around it.
Yeah.
And it will have a surface. And if current starts flowing, generally you can say that the surface will be more negative because Lenz's law and current flow and so forth. Because usually plasma is not completely even. You're going to get a hum in there of vibrations. And so you're getting inductances all across this whole thing just humming away. And so this would be your environment. Now, if this was a larger enough ball, you could also start getting rotation because it's inside a field, and something would cause, it would start generating, if it's iron, for example, it might generate its own magnetic field as it starts getting its own homopolar motor effect with the torus and everything. But if not...
Are you recording this still?
Yeah.
Okay, good. Continue. Because you're doing a wonderful job there. So if I have that system that you just imagined, now imagine that iron ball, let's say it's 10 centimeters diameter, and I put in 3 millimeters of sand all around that ball.
It's going to stick to it. It's going to weld to it.
Okay. Where do the electrons flow? Is there any change there, or are they still sticking more or less to the metal?
Well, since these things are, if you're just starting to, for example, there's no atmosphere and we're just talking rarefied plasma, obviously there's going to be a flow of sand because there's no gravity, so it's just flowing, and it's going to go.
Okay, let's say the sand deposits. Will the electrons flow in between the sand on top of the iron?
No. I didn't mean. No, I meant looking at, like, let's imagine this ball in front of us with these 5 balls as a sphere that you're talking about, just like that. I meant that it wouldn't fall to the purple floor below. I meant so it's flowing across it because it's in the sand wind, which is an electric wind now, because these things are actually carrying a charge, because now they in turn are doing the exact same thing. Each piece of sand will have its own cloud of electrons around it. And then these things will now able to conduct. That's what makes a dusty plasma conduct in the first place. That's why you get dust devils. So this is now able to connect and move charge around. So it's now going to concentrate. No, hold on. It's going to concentrate itself because now it's generating its own magnetic field as these charges flow. So now it's becoming a Birkeland current of sand. Now this sand is going to hit this ball in wherever it does. And in so doing, will likely try to, because as it gets in there, it's going to, its own cloud is going to reionize these particles, and they're going to want to stick to this ball. And this is, those type of things will happen, if you get my meaning.
So we reach a state, assume, we reach a state whereby the sand is more or less welded across the globe or across the ball.
Okay.
It's not movable no more. It turned into rock.
Yes.
Granite. Quartz.
Yes. As charges go through it, will change the rock into different things. The sand will change.
But now the electrons, the electric currents in all those resonance patterns across that globe, across the surface, are still there, right?
Well, now you've done something crazy. See, now that you've put a shell on it, you've actually made a dielectric barrier between its regular core and the layer outside. So now you're going to have a different field. And it's going to change the nature of this object. It's going to probably create a larger field around it, because now the charges are deeper. So now you can have the difference can be higher, and the voltage should increase.
So the charges are basically on top of the metal still, despite the thickness of the layer of rock.
And let's not even get started what happens when you start raining on the thing with water. But
exactly. So what you just described is the Earth. Thank you, Neil.
That's not actually me. That's just an inference of actually the statement made by Tesla long ago when he said, the Earth is nothing but a small metal ball immersed in an electric field or something, or a magnetic field or something.
Exactly.
Because that's all we are. There's nothing strange about it at all, in my opinion. In fact, when we were birthed from whatever planet we came out of, whenever or however that happened, the surface was probably pretty much welded onto it. And it's possible and quite likely that if there's a situation that happens in electrical events, like when a pinch happens, sometimes you'll just get one ball or a pair of balls or whatever that come out of the pinch, right? But sometimes you get a shotgun blast of balls that just come out like a ton of little spheres, okay? Then those spheres become their own electric current themselves, because they are like dust. So these spheres then will actually conduct a charge and create a bigger pinch that crushes all of those spheres into a sphere. So that would be, if you go back to the 1850s idea of how the Earth was, then under natural philosophy, they said it looks like a bunch of misshapen things that have, like, because they were counting the volcano rings, right? They're starting to get an idea of what we looked like, that we're a bunch of chunks of material that were crushed together and then again coated with another bunch of silicates during that event. And that could have all happened. And so now we have charge differential inside of our own self. And that's what makes the Earth different than other bodies. It seems to have, so there is something special about the planet, because it has these properties, but because it seems to have charge will travel from one thing, but it can't get through to another part of the Earth. And this constant mangling of our electric field is, it's creating heat and everything else. There's definitely some resistance going on there that makes Earth very interesting. And I don't know how water comes into it, but it's there's something there. So,
well, that's where we're going. Water is the key in the end. But what I hear you say in this comparison is that our own Earth, which is a metallic ball from the mantle downwards,
Probably.
and the crust is basically more or less metallic-like, but not really metal. But below it is the metal. So what I'm hearing you say is just above the mantle, deep down in the crust, is where a huge bunch of energy or electrons are pushed around by the daily cycle. Remember the Telluric currents?
Yes.
So all these electrons discharged there
in loops, by the way,
pushed around daily.
Not only daily, but also every 7.83 seconds for the Schumann resonance. So there will be a slight vibration also causing other little eddy loops through this whole thing.